This is incredibly preliminary work. When we submitted, we were very sure we were going to have data. And then we went back to the drawing table, and we're just, I'm not going to show you data. I'm just going to show you a tiny pilot that has a little bit of a methodological twist that I think is cool to talk about. So this is joint work with Elena Asparouhova of the University of Utah and Milo Bianchi from Toulouse School of Economics. And we're asking the same question Gustavo is asking, but from a very different point of view. So we just want to know the issue. Well, it's a little bit different. Our concern is how does the human preference, the risk preference, how does it get integrated into whatever robo-advice the robo-advisor is gonna transmit? And to try to explain where we're coming from, we are academics, so we're coming from academic literature that leads us to be skeptical about the possibility of doing this, or concerned, not skeptical, concerned about this aspect, okay? So algorithmic advisors, we think this can be super cool because advisors in general may be better at handling complexity, information, and portfolio optimization than a person, an investor, a retail investor themselves are. We think algorithmic advisors are particularly good at optimization, right? This is just usually it's very simple formula. Mean variance optimization with a handful of securities is a very simple mathematical formula. You're millions of light years away from needing artificial intelligence. It's very simple computation. And moreover, algorithmic advisors may be cheap, less biased than a human advisor. A human advisor may be also led by incentives in their bank or wherever it is that they're working for. And they may be, instead of being biased by the incentives that they are given, they may be, the investor may bias them as they want. For example, they may want to have an impact or an ideological type of investment that they can impose on the robotic advisor to adopt as a bias, okay? Finally, algorithmic advisors may, for incentive reasons or for complexity management reasons, tap into a larger set of securities than your typical human advisor may tap into. Okay, so if you go, in particular, you go to your bank's advisor, they have a very limited set of securities that they will be looking at when they advise you. Okay, so, but how can the advisor know the investor's preferences? Or more specifically, risk preferences, right? What is my risk aversion? Okay, so what does the literature tell us about this? There is a trade-off here. So humans are bad at optimizing. There's poor optimization skills. We have an enormous literature about this. Households typically under-diversify. The first papers about this go back to years before most of us in this room were born, so 1975. Bloom and Friend, this is archival data, works as this is done on data on investor choices in the 60s. Gutman and Kumar pick up this work in 2008 and arrive to the same conclusion that there's under-diversification. Too frequent trading, we all know about this. Barbara and Odin have made the point that people trade too much, pay too many fees, and hold on to losers, sell winners. So this is the disposition effect. And all of these things lead to portfolios that underperform the market, but not only underperform the market in terms of, so they underperform the market in terms of Sharpe ratio, but they don't necessarily have lower riskiness, right? It's not necessarily driven by consideration of risk aversion. Households also have poor financial literacy. This is the trend right now to talk about financial literacy. Recent data, European Commission survey in 2023 shows that only 52% of Europeans qualify as financially knowledgeable, which means that they answered 3 out of 5 questions on financial literacy correctly. This is considered financially knowledgeable. There is one of these questions is about compounding interest rates. This is a question that we think is quite fundamental. And the European question was harder than the US question, and that explains the difference here, but only 45% of persons get it right. A question on compound interest rates, and in the US, an easier question, only 69% of people get it right. And finally, even when you go to the lab experiments, there's very old evidence that people don't understand correlation and diversification, the role. So when they're asked to diversify their portfolios, they don't understand that they should be adding things that have low correlation with their portfolio instead of things that have high correlation. When we say investors, when they're on their own, they do poor choices, but market forces will lead them to do correct choices. And I've worked on experiments like this, but I'm citing the seminal work, which is Bossarts and Plot 2004. I have done this work as well myself. You can get, even when you have in the market, people, there's convergence to equilibrium prices in the markets, but when you look at the individual portfolios of people, you have the median, of course, being at the market, but the rest of people are under diversifying most of the time. Okay, so poor at optimizing, but on the other hand, poor at knowing themselves or expressing themselves. When we try to figure out people's preferences, and that's what a robo-advisor potentially will be doing, we also have a problem, okay? And so here, this is going to be all about risk aversion. A very useful theoretical construct, going for mean variance, which is MVO, which is what most robo-advisors are doing, which is what Gustavo just showed us. It's a good approximation, if nothing else. So risk aversion really, really matters, right? Even if people don't have MVOs, preferences, this is a very good, it's the first approximation we want to go for. And so risk preferences, unfortunately, are very elusive. When we try to elicit them, there's something even called the risk aversion puzzle, pointed out by Pedroni et al. In 2017. There's inconsistent elicitation across methods, or you repeat the same method twice and people will reveal different risk aversion levels. If you do different methods, you get huge differences in the risk aversion that people give you, express, okay? So this suggests that perhaps preferences are being constructed as you go, or people are learning their own preferences, or there's instability out there. We have Gnisi and Potters, which was the paper that at the beginning inspired us, but we have moved so far away from them. They have that people, when they invest, so now we're not talking about asking people with a questionnaire what their risk preferences are. We have them investing, and as they invest and you give them feedback at different frequencies, they change the type of risk aversion that they express with their portfolios, okay? So even when you have the factual information about their portfolios, it's not clear you can extract risk aversion from that. And there's some work in 2020 by Arsen et al. That end up saying, well, qualitative assessments may be the better one. So your questionnaire may actually be less bad than you think it is. Okay, just 2 more important works that I want to mention. Bashir, Choi, Leibson, and Madrian, and Caponi et al. These are papers that say, okay, we have a problem here with people expressing their preferences, but there are a certain amount of things that we know are errors. So we should be able to find a midway. Even if we don't know their preferences correctly, perfectly, we should be able to help them. Okay, and there's, in Caponi and all, they actually propose a way in which people should be interacting optimally with an algorithm, or how elicitation should happen optimally under a series of assumptions. It's a theoretical paper, to get an improvement in the investments that they make with respect to what they would do without the help of an algorithm. Okay, so all of this said, what are we going to do? So we're going to focus. So I've submerged 2 things in one so far. When I gave you the previous slide, I said people may not even know their preferences, okay? Because when we try to elicit them, we get very confusing answers, okay? So now we're gonna actually split this up into two pieces. We're gonna imagine you know your preferences, and we're gonna focus on expressing them only, okay, communicating them. And how are we gonna do that? Well, we're gonna induce preferences in the lab. That's gonna be our take. So we're not gonna have people facing real risk. What we're gonna have people face is they're gonna have a payoff that is gonna be the mean variance utility attached to a portfolio that they invest in, with a risk preference that we give them, okay, that we impose on them. So participants don't face real risk. We're gonna have them construct portfolios that we then translate or transform into a risk-adjusted payoff, depending on the mean and variance of the portfolio payoffs. And so we abstract away from the question of preference construction, and we're going to focus only on the communication of the preferences. As you learned from my previous slide, this is abstracting away from the bigger problem, right? The bigger problem is we don't know whether people truly have these risk preferences or not, but now we're just going to go to the other. So we're going to have two types of investment tasks. We call them, we're going to give them different names, but they're both going to be somehow investment tasks. One of them is going to be the risk tolerance or risk aversion elicitation task. It's going to be just a simple binary lottery, and it's going to be the same task each time. And then we're going to have payoff relevant tasks, investment tasks, which are the ones where the robo-advisor will participate, okay? So this is just where you communicate your risk preferences to the robo-advisor when there is a robo-advisor. And the other one is where you will get your payoff. This is where you're truly getting something from. And we're going to have experimental manipulations, presence or not of a robotic advisor, and what information and how often does a robo-advisor learn about preferences. Research questions. Okay, so I'm going to jump to the second slide on research questions. The first slide I will comment on. So the main questions is, when will the decisions be better? And we have a definition of better. Our definition of better is we know your mean variance utility. We impose it on you. When will it be closer to the optimum for those risk preferences? Okay. So when, with or without an algorithmic advisor, we're going to be particularly interested in separating early and later interactions with the robo-advisor because there's this risk elicitation test that we have designed on purpose to be repetitive, and we hope people will become better at that, even though they're not becoming better, perhaps, at investing in very changing economic conditions. Okay, so this is the hope that we have for the robo-advisor. So what happens with experience is something that we're particularly interested in. And then when we have a robot, we want to know whether allowing people to express their preferences to the robot more frequently is a good thing or a bad thing. And this is inspired by Gnisi and Potters. So at the very early stage of this research, we were coming from there, where they have this more frequent feedback on investment performance that actually leads people to invest less in risky assets, to become more risk averse, apparently. So we were thinking perhaps there's going to be a bias like that. We have moved very, very far away from there, but we're still keeping the frequency question in. And finally, do people recognize good advice? Are they able at least to recognize good advice and follow it? And what bias may the robotic advice actually introduce to choice? Okay. So here's our experimental design. I'm committing, by expressing it publicly for the first time, I'm committing to it. This is almost a pre-registration, but we will pre-register. 16 investment rounds, where you get to split very little, $10, but you can think of it as 10 million if you prefer, okay? So we haven't decided how we're gonna tell people, whether we're gonna keep it the real thing, $10 between zero interest deposit and market index. And the market index is what's gonna have changing economic conditions. Okay, so this is a very simple choice. So what we're doing is we have a lab experiment here. We're taking everything to the simplest expression, and we'll see what we can get out of this. Economic conditions mean that the market index expected return and variance changes across investment rounds. Okay? So this is the only difficulty that an investor investing on their own could face. Like this thing is changing, so I don't know anymore how I want this split to be.
So
okay. Yes?
Can I ask, what is again this investor risk penalty? Is part of the...
It's part of, I impose it on them. This is what I'm going to tell you immediately here. This risk-adjusted payoff. Okay. So the other thing about the investment rounds is that I group rounds in blocks, and I'm going to have every 4 blocks, I'm going to change the risk aversion artificially. I'm going to change your risk aversion and see if you adjust and express it correctly afterwards. Investors are paid according to a risk-adjusted payoff, this RAP, which is actually the mean variance utility. So what if they choose to invest X in the market index, they will be paid X times the return, the gross return of the market index. Whatever they don't invest in the market index, they keep. It's a zero interest, it stays in a zero interest deposit. Minus a risk penalty. And this gamma, this is what we control. Okay, we control. I don't know to what extent we control. We try to control. We tell people their gamma. We tell you this gamma is going to be 0.1, it's going to be 0.4, it's going to be 1, whatever it is that we decide it is, times the variance of your investment, of course. Okay, and finally, since this, okay, so this is great. This is our mean variance utility. But it's very difficult with the money amounts that we have in the lab to get incentives to be steep enough. Okay, so we want incentives to be steep so that their choices will matter. And so to do that, we transform RAP. We take 9 out of it and we multiply it by 10. So there's going to be the difference with respect to 9. So how much more than 9 did you make? Why not 10? So 10 is your basic amount of money and what you get if you invest 0 in the risky assets. Okay. Why didn't we use 10? Because then we would have a lot of chances to go negative. And going negative in the lab is a problem. Okay. So yes, we are facing lots of issues with that, but we will take the chances of going negative and see what happens. Okay. And so this makes it a little bit steeper. This is how we will pay them. An important thing in our setting, and this is something that you can tell me since you've done a very good search of what is going on with robo-advisors around the world. Our robo-advisor is just an advisor. I can decide not to follow their advice. Okay, so the persons in the lab will be allowed to not follow the advice. Okay, always. And then we have 2 experiments in the making. One experiment is the one that my talking has been focusing on. In the beginning and after every 2 or every 4 investment rounds, there's a risk aversion elicitation round. Okay? And this risk elicitation round is a choice of an investment in a binary lottery, and it's the same lottery each time. So it's a very simple, we believe it's a very simple task. It's a simpler task than going for a market index, or people will feel more close to this task. And it's the same task each time. Yes?
So this is always unfair when you do an experiment. People are asking about, general validity and whether that mimics the real world. But in the real world, it seems like trust in your advisor and trust in potentially a robo-advisor would be key, right? There's this theory that investment advisors are more like money doctors. And
yes. Janayoli and
convince you to do things, but I never know when I talk to a banker or a broker whether they have incentives to sell you one product versus the other.
Yeah.
So it goes beyond like the fraction of a portfolio in one versus the other. But in the context of your experiment, what do you tell them about the robo-advisor? Do you tell them it's going to make the right optimal decision from an economist viewpoint, and then we're going to observe what you do? Like, how do you present it?
Like you said. We're going to say
it's... telling them this is ideal. Let's see if they follow the ideal.
Well, it's ideal given the risk aversion that you expressed, given their understanding of you.
So it's more of a test of whether they understand the risk aversion, or is it a test of their trust in the robo? How do you think of their choice?
It's how I think of the choice of my persons, my humans. Whether, for example, if they decide to overrun the robo-advisor, the only reason to do it, if they understood everything, is, oh, I did not express my risk aversion correctly to them. Okay, so my robot didn't understand my risk aversion. That's the only reason, or they didn't understand stuff. That's the other reason. There's two reasons for overrunning your robo-advisor is I did not communicate my risk aversion correctly. He didn't understand it correctly.
You're being given risk aversion.
But they're not allowed to tell they're not going to tell the robot, my risk aversion is 0.05. What they're going to do is they're going to participate in a repetitive task, right? That is going to express this. They're going to use a task to express their risk aversion, okay, to start with. So this is the part where it gets minimally realistic, okay, which is where you're not going to tell a robo-advisor, my risk aversion is 10. We don't even know what that means, right? Out of context. So okay.
So might you factor in your participant choices a general algorithm aversion component, maybe, or
we weren't thinking about this, even though Milo, my co-author, he's worked on algorithm aversion, right? But we weren't thinking that a reason for not going with the advice of the robot is just algorithm aversion. But I think it's something that we will have to factor in. We haven't considered it theoretically at the onset. We should. Yes, thank you. And so this is the experiment 1, and I'll tell you more about this. Experiment 2 is a situation where you don't have an elicitation task. There's no elicitation task. You're just investing, and the robo-advisor, so you're investing, you're getting advice, you're potentially overrunning the advice that you received, and the robo-advisor learns from your choice, okay? The robo-advisor each time takes information from your choice to try to, it's very easy, in our case, it's very easy to extract your risk aversion from choices. It's completely straightforward, okay? So experiment 1, more details about it, and then since I don't have data, I'm not gonna run out of time. Now the effort is explaining the risk penalty to our participants. What does this risk penalty actually mean? And so we use an example to do this, and we tell them, well, how you would choose optimally depending on the risk penalty. We try to show them in a test. Well, we don't show them this graph because this graph is very bad. I only realized now that I forgot to truncate it when I regenerated it. I changed the parameters this morning. It's truncated so that you actually can see, it's truncated at 10, so that you can see the different investments. I didn't realize this. And this gives them an idea how they should, how sensitive to risk, what does it mean, this 0.05, or what does this 1 mean, etc. And then, important, we have to give feedback to our participants. And the feedback that we will tell them is, well, we will tell them, initially there's the robot that tells them their choice, then they decide to overrun or not and what to invest. And then we tell them the performance from their choice. And we debated a long time about this because this is not realistic at all. But we tell them what would have been the optimal, the maximum that they could have obtained, okay? But we don't tell them the choice, the optimal choice, but we tell them what they could have obtained if they had chosen perfectly, optimally. Okay, and then the treatments, there's one where they invest on their own. There's another one where we elicit risk aversion infrequently. And so infrequently means only once for every risk aversion that you have. And another one where we elicit it twice in every block. And now, the no data, hypothesis, I've been talking a lot about that. The no data, but the no data is actually quite cool. And I'm just gonna make some propaganda for this PhD student, Arman Budarzi, at the University of Utah, together with Elena Asparouhova, my co-author. They have been working well, there's another paper that I have to refer to, but it escaped my mind right now, that has been replicating experimental data with AI personas. Okay, so you have artificial intelligence personas, and the interesting thing to do there is you can base your AI personas on all the information that was collected on the sample in the experimental work. So some demographic data, but you could also have financial literacy data or other data on your people, and then you can replicate, you can tell this information to create AI personalities, and you can try to replicate the experiment with participants that are artificial intelligence. And so far, for some of the very nice papers, I mean, you can think of this as another validation of whether some of these characteristics determine your choice or not, right? And so far, they have replicated quite a bit of results using this type of artificial intelligence. So we have run our pilot with 6 AI personas defined only on demographic characteristics, and I'm just going to tell you what these 6 AI personas have done in our experiment. And so this is more for fun. Well, it's instructive for us to moving forward. It's more for fun than anything else. In the baseline where you invest on your own, you can see optimal choices are in blue, and what the people choose is in orange. And we have our 6: Tyler, Rajesh, Maria, Margaret, Linda, and David. By the way, the personas are created in Gemini. Okay, and they don't choose optimally, but for example, Rajesh here is very close to optimal. So they're not far away from what is optimal given the risk aversion level that we impose on them. And this is an average across rounds. Okay, this is not this is all the rounds that they participated in. Now, treatment 1, when we elicited the risk aversion only once in every block, as you can see, they're apparently informing the robot pretty poorly about the risk aversion, our AI personas, because the suggestions of the algorithm are on average worse, a little bit, I mean, it's very suggestive, but on average, they seem to be worse than what people would choose on their own. Okay, and then when they correct it, they remain pretty close to the suggestion of the robo-advisor, actually. So the introduction of the robo-advisor here was not necessarily a good idea. Then we have the second treatment where they're allowed to express the risk aversion twice. Like they have a second chance to express the risk aversion to the robo-advisor. And there, of course, things look a lot better. Okay, so the robo-advisor actually gives better recommendations, and they remain very close to it. And we have always the correction, almost always the correction that they do. Not all, no, forget about what I said. Okay, and then finally, how often do they follow what the robot tells them to do? It turns out that when they are expressing the risk aversion only once, their follow rate is higher. Okay, so they actually correct the robo-advisor less when the robo-advisor is more accurate. So they have, it should be going the other way around, but they follow it more when the robo-advisor is giving them poor advice. Okay, so this is just some preliminary. I gave you an experimental treatment. This is my presentation. The data are not there for fun. They're just fun stuff that I told you. Okay, so that's it. I cannot give you conclusions without the data. Okay. Yeah.
Thank you.
Yeah. Questions?
I'll ask.
Yes.
So with robo-advisors, from what I've seen, so usually when there's a downturn, it's a matter of these people not having enough of their wealth, so they panic and they just take out their liquid investments, even if it's better to maybe buy up assets at that time and invest. So do you consider right now like initial wealth, like they're more likely to panic in an economic downturn rather than when everything's going well and going up?
Yeah. So we talked a lot. The 3 co-authors. We talked a lot about heterogeneity in endowments in the beginning. We have moved away from that. Okay, so right now we're just focusing on this issue of communicating, and we're gonna do many things for it. So as you saw, the experiment 2 is about communicating with your investment. So it's just about that. And then we'll see, because the robo-advisor is so good at correcting many things, and one could focus on one issue, for example, will the robo-advisor prevent you from making that wrong decision of pulling out your money? That's something we're not doing for now. We're not thinking about. Yeah. Yes?
I have one question about the risk aversion. I think it's a bit a two-sided thing because when you look at for Germany, so for German investors, they're way too risk averse, so they don't invest a lot in the long term, like in equities, which would be beneficial for most of them. But if you would ask them about their risk aversion, they don't want to lose anything, and they don't have in mind that in the long term, in the past,